friends, this is a video in continuation with our discussion on portfolio risk. Friends, in the previous video we have seen how we compute a portfolio risk when we have just two securities. Today we will see if there are more than two securities, how can we compute the portfolio risk. So friends, let's see that there is a portfolio where there are securities A, B, C, likewise there can be n number of securities. How can we identify or how can you calculate the portfolio risk? In the previous video we have seen if there are only two securities, the computations are not that complex. We make use of a table called variance covariance matrix. So similar way we are going to do the portfolio risk, assuming that there are three securities or more than three securities also. So first I'll tell you how we will compute, and then we will follow to pick up a problem and see how can we compute the portfolio risk. So friends, what we will do, we will write here A, we will write here B, we will write here C. Likewise we have A here, B here and C here. We will be constructing something called variance covariance matrix. So friends, this part, that is A and A, this part, so let me just draw a few lines so as to make it more clear, that you see this is a matrix having different cells, right? Now friends, you can see this cell represents AA cell, this represents BB cells because the column is B, row is B, and this one represents CC cell. What I mean to say that the diagonal part of this matrix means this and this represents security variance. So friends, this will represent the variance of security A. So we know that variance is a measure of risk of individual security represented by this, okay, of security A. Right friends? So we have something called WA square. That means how much money I have put in security A is proportion times the variance of this security, right? Here it will be variance of B times variance, the weightage of B times variance of security B. This one will be variance of security C. So friends, this way, this diagonal part of the matrix represents the variance of individual securities. Right friends? Come to this. This is B and A. That means there is a covariance. As we know that whenever we were identifying risk of a portfolio, there are two types of risk: individual security risk, A's risk, B's risk, C's risk, and the interaction risk that represents the covariance between them. Okay friends? So we will write here the covariance between A and B, right? So we will write here, as you know that correlation is equals to covariance, correlation between A and B is covariance of A and B time divided by standard deviation of A and standard deviation of B. This is the formula that we have discussed in one of the previous videos, that correlation can be obtained between A and B by this formula. So if I have to compute what is covariance, covariance of AB is nothing but correlation of AB multiplied by standard deviation of A times standard deviation of B. So that means covariance is this. So we will put this formula here. So this is BA column. So it is correlation between, mind it, we have to, just one second. Friends, what we have to do is that we have to write here weightage of A times weightage of security B times correlation of A and B times standard deviation of A and standard deviation of B. So this is the covariance between A and B. Similarly, this is C and A. So weightage of A, weightage of C, correlation between A and C times standard deviation of A and standard deviation of C. Come to this, friends, this is A and B. So weightage of A, weightage of B times correlation of A and B with standard deviation of A and standard deviation of B. Friends, this is C and B. So weightage of B, weightage of C, correlation of B and C times standard deviation of B times standard deviation of C. Friends, this one is AC. So weightage of A times weightage of C times correlation of A and C times standard deviation of A times standard deviation of C. Coming to this, it is B and C. So weightage of B times weightage of C times correlation of B and C times standard deviation of B times standard deviation of C. Friends, our matrix is complete. Hope you have understood what I have done. I have taken the individual securities variance. If you have confusion, please refer to the previous video where we have discussed about the individual securities risk. This is the covariance between the two securities as derived from this, and this way I have completed the matrix. Now friends, when I have to find out the portfolio risk, I will sum all these, I will add all these, and whatever I get is the portfolio risk. So it's simple. Only thing that you have to put the appropriate values in the appropriate cell. So friends, we'll take one case and see how this portfolio risk through this correlation variance covariance matrix. This is called variance covariance matrix. Variance covariance matrix, we can take help of this to find portfolio risk. Let's pick up a problem. So this is a problem that I have picked up just to illustrate how portfolio risk can be ascertained. Friends, we have three securities and you see this is the standard deviation 30, 26 and 24, and these are the correlation coefficient because we need correlation coefficient for computing this risk. And equal weightage, that means let's believe that A, B and C, if I have 100 rupees, I have equally distributed 100 rupees in all three. That means 1/3, 1/3 and 1/3. So it becomes 0.33, 0.33 and let's say 0.34 also you can keep, let's keep it 0.33, right? So this is the situation, let's compute. So friends, you see these are the three variances. Let's write the variances first. Of security A plus security B, security C plus, friends, we are done with this and this. Now we are writing this covariance. One thing you notice, this one and this one is the same. WA, WB, correlation AB, these two are the same. So twice I can write WA, WB, correlation AB times standard deviation A, standard deviation of B. Plus, that means this is done, this is done. This and this are same because this is AC, this is also AC. So we can write it twice. WA, WC, correlation of AC times standard deviation of A, standard deviation of C. Plus, that means this and this is done. Now you see this and this are same, right? So WB, WC twice. WB, WC, correlation BC times standard deviation of B times standard deviation of C. So formula written. Now let's write the values. So what we want, weightage of A. As I am telling you, the weightage of A is 0.33 square times standard deviation. This is variance. That means variance of A. You can see standard deviation of A is 30. So when we square, we get the variance. So 30 square. Right? So we have written this and these values plus weightage of B is same 0.33 square times what is the standard deviation of B? 26. So we'll write 26 square plus weightage of C, so it is 0.33 square times what we have to multiply, the variance of C. The variance of C is 24 square plus, now we are coming to this part, 2 times, I'll just rub it, okay, so 2 times, what we will do, weight of A, weight of B, so 0.33 into 0.33 into correlation between, sorry I am here, weight of A and weight of B, then correlation AB, so you can check, the correlation between A and B is negative 0.50, sorry. So weight of A, weight of B, correlation of AB times standard deviation of A is 30 times standard deviation of B is 26. This is done. Okay, so plus, we are coming to this one, 2 times weight of B, weight of A, weight of C. Weight of A and weight of C is the same, that is 0.33 square, or we can write 0. How we are writing here? 0.33 into 0.33 into correlation of which one we are doing now? We are doing the second one, that is correlation of A and C. Correlation between A and C is given here 0.60. So into 0.60 into standard deviation of A is 30 into standard deviation of C is 24 plus. Now we are left with this one plus, we can write 2 times weight of B, weight of C, correlation B and C is 0.40 times standard deviation of B is 26, standard deviation of C is 24. So friends, if you simplify this, you will get what is called portfolio risk. You have to be very careful in your computation while writing these values against these formulas. If it is done, what we get is the portfolio risk. So let me calculate and tell you what's the portfolio risk. So the computation is done. So if you simplify, you will get the portfolio risk result is 297.84. And once you find the root of it, you will get the standard deviation of the portfolio. So variance of the portfolio is this and standard deviation of the portfolio is this. So friends, we have covered how we can calculate the portfolio risk if we have n number of securities. You can go on computing with the help of a covariance variance matrix, where you put A here, B here, C here, D here, E here. Here also horizontally A, B, C, D, E. Go on computing the variance and covariances. The diagonal axis or diagonal cells will represent the variance and the other cells will represent the covariance. So friends, you can see as an investor, I know this is the portfolio risk, right? Now, should I invest money in this portfolio? This is this much risky. I can do this, I can take this decision only when I compare this portfolio with other portfolios and then select the best portfolio, right? So this portfolio has got this combination ABC with equal weightages. I might like to alter the weightages, may change it, make it 60, 20, 20 or 30, 30, 40. This way I may change the proportion and see what is the portfolio risk. Okay, so as you change this composition, or you may delete one security, add another security, you will find that the portfolio riskiness is changing. So if you have this weightages altered, you will find of course your expected return will also alter and your portfolio risk will also alter or change. You need to select that portfolio which gives you the maximum return and the minimum risk. So in the next video, we will see how do you can find out the efficient portfolio. Thank you for watching this video. Do watch the next video, and for the links of the previous videos, do go through the description box. Thank you. Bye-bye.